Hey everyone, so this video will be about operators. Every programming language has these special symbols or keywords that are part of the syntax, and they do something, an operation with the operands, and operands are the values or the variables that are used by the operator. So there are different types of operators, and every language has its own symbols, maybe the same operator, the same functionalities resembled in different operators or different symbols that represent the same operator. So we'll cover the most common ones that are present in almost all languages in one or other form. So let's go through the list of these operators, and then we'll have another video where we just write some simple small programs where we'll use all our so far acquired knowledge about variables, data types, and operators. So the one of the most important operators, I think, is the assignment operator, and that is usually represented by an equality symbol. So when you write a equals 5, or we say var a equals 5, or set a or int a equals 5, we assign value 5 to the variable a, and equals there is called assignment. So one thing about operators, they all have when we write an operator, all the operands with the operator, they form an expression, and this expression has a value. So when we evaluate, when the program runs and the expression is evaluated, it has some value and a type of that value. So when we write int a equals 5, since the a has a type of integer, the type of the whole expression becomes integer, and the value of the expression is whatever we assign to a. So the value of the expression is 5. So assignment operator always has the value of what we assign, and it has the type of, it depends on the statically typed or dynamically typed language, but it's either the type of the value that we assign or the type of the variable that we assign to. So then we have the arithmetic operators, and they basically do the simple arithmetics like addition, subtraction, multiplication, division, and there is actually one more which is common to most of the programming languages. It's called the remainder, or the modulo operator, which is written represented by the percent sign. So you write a%5. It means divide whatever value a has by 5, and then take the remainder. So it works on integer types, and the value of the value is also an integer. The value of the expression is with the modulo operator is of integer type, and the value is actually it returns the remainder, as I said. So the addition is represented by the plus sign, then there is subtraction by minus sign or dash, and division is the slash, and multiplication is the asterisk. Those are the common symbols. There might be exceptions in some languages. So all of these arithmetic operations are binary. Remember that binary operators, not operations. The binary operators are those that take two operands and they operate on both of them. So then we have the unary operators, plus and minus, which just determine the sign of the value. So it applies to all numeric types, and if we want to say -5, for instance, we write -5, right? The same way, if we want positive type, we can write +5, but usually by default it's always positive, so no one really writes +5. but it's there, the operator is there, so it's unary because it takes just one argument or one operand. Then we have a couple more unary operators which are called increment and decrement, and which change the value of the operand by 1. So increment is written as plus plus and decrement is minus minus, and increment is adding 1 to the value, to the operand. Decrement is subtracting 1. And in some languages we have 2 types of these operators. So each one comes in 2 forms. One is prefix, one is postfix. And what this means is prefix operators come before the operand. So you write plus plus a. And postfix you write after the operand, so a plus plus. So the difference is subtle. The effect is the same. So plus plus a and a plus plus, they do the same things. They increment the value of a by 1, but the subtle difference is that the prefix operator, it increments the value by 1, and the value of this expression is actually the final value after increment. But when you write postfix, you get, in the end, you still get the increment by 1 to the operand, but the value of that expression, a plus plus, is actually the value of a before the increment. So we'll see in the future how it's useful, how we can use it, leverage that, and save some additional lines of code. Then we have the relational operators, and those are used to evaluate some expressions for which are really like conditions, for checking some conditions. And that means, or that's equivalent to saying that the expression type, the type of the value returned by relational expressions or expressions with relational operators is Boolean. So it's either true or false. And we have the equality operators. So we have when you say equals, we want to compare 2 objects, if 2 values, if those are equal. Let's say if we say a equals 5, it means it will return true if the value of a is 5, and it will return false, not return but evaluate to the value of false if it's not 5. And the symbol for writing equal is the equals mark twice, so double equal. In some languages it's written as like EQ as a special keyword, and there might be others too. So then we have not equals, which is the opposite. So it evaluates to true if the 2 operands are not equal, and to false if they are equal. So the common symbols for the non-equality operator are exclamation mark equals, and or the less than greater than, or there is NE, NEQ, or just standalone not and then EQ. So different languages use different syntax for the same operator. So those 2 are called the equality operators because they check if the values are equal or not equal. Then we have other relational operators. We check the relationship of values in terms of which one is greater or which one is less than the other. So we have the common ones. We have at least 4 types, which is less than, and then less than or equal to, greater than, and greater than or equal to. And the most common representations are either the less than, greater than, and less than equal, greater than equal signs, like in math, or some languages use the abbreviations GT, LT, or GELE for respectively greater than, less than, or greater than or equal to, or less than or equal to. So those are the common relational operators, and as I said, all of them evaluate to a Boolean value, so it will be either false or true. Then we have another set of operators that evaluate to Boolean, and those are called conditional operators. So those are for checking either a combination, So if we have two Boolean values or expressions and we want to check some sort of combination of those values, we use the conditional operator. So the first one is the not, which means if we have a value, we want to evaluate the opposite of that Boolean value. So it's written as the exclamation mark, or some languages just use the written, like in English letters, not. And it's called negation or logical complement. So whatever the original operand has, whatever the value of the original operand, it just takes the opposite or inverts that value. So if the operand has value false or evaluates to false, then the value of the not operand will be true, and if it has true, then it will be false. So we can say if this object is green, then do something, right? And then we can say if this object is not green. So that's the usage of the logical not. And then we have logical AND or conditional AND and OR. So you should not confuse this with the bitwise OR and 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 OR, because these sound similar, but they do completely different things. So conditional operators apply to Boolean values. Remember that all the expressions are evaluated as Boolean expressions, and then these operands are applied to these Boolean values. So what AND does, it's written as two ampersand symbols. So double ampersand is AND. Some languages just have AND. And what it does is it takes the first value, the first expression or operand, and evaluates its value. If it's true, then only it evaluates the second value, and the value of the whole expression that this operator returns is true only if both values, both operands, evaluate to true. So if I say if this fruit is round, it has a round shape and it is yellow, then print orange, right? So it will only print orange if both conditions evaluate to true. And one nuance of this operator is that if the first expressions are left side expression operand evaluates to false, it means that no matter if the second operand will evaluate to true or false, the logical AND will always return false. So there's no sense in even evaluating the second operand. So in this case, it will not do that. So most of the languages will skip if the first one is false. So if we say if A and B, and first the value of A will be calculated, or the expression A will be evaluated, and if it's false, the second one will not be evaluated because the result is false anyway. So similar to this, we have this conditional OR or logical OR, and it's written as a double vertical bar, or some languages just use plain English word or keyword OR. And it does a similar thing, just in this case it evaluates to true if at least one of the operands evaluates to true. And in this case there is also this short circuiting in case if the first operand evaluates to true, then by definition the result will evaluate to true. The result is true, so there is no meaning in evaluating the second one. So if we say if this is a boy or a girl, then it's a human, right? So if we check this is a boy, it's true, then there's no meaning in evaluating the second condition. I mean, this is not a really good example, but just, yeah, let's, in terms of logic, it just always evaluates the first one first, and then the second one will come. The second one will be evaluated only if the first one returns false. So these are AND and OR. The next one, the not negation we covered. Then there is one more operator. It's I don't think it's as common as the previous three, but it's still very common in all the mainstream languages, so we'll cover it. So it's called the conditional ternary operator, and it's written as question mark and colon. So the way it's ternary because it takes three operands. So the first operand is a condition that will evaluate to Boolean value, and that comes before the question mark, and then we have the first expression, first statement after question mark, and then colon, the second statement. So if the condition evaluates to true, the first statement will be executed. If it evaluates to false, the second statement after colon will be executed. So we'll come back to this when we cover the control flow statements in a separate video, so we'll talk about this more there. So these are all the conditional operators. The next group is the bitwise operators. We've pretty much covered all of this in the video about the binary system and binary numbers, how they are represented, but just a quick recap. So we had the bitwise NOT or negation or inversion, which is just flipping the bits, right? So if we have 1, it turns them to zeros, all the zeros turn into ones. So that's negation or NOT. Then we had the shifts, arithmetic shifts, which are just shifting all the bits either left or right, and then the left shift always fills the incoming bits with zeros, the right shift fills, depending on the value of the most significant bit or the leftmost bit, it will either fill with ones or zeros, so it preserves the sign. And then we have in some languages we have the logical right shift, which ignores the sign bit and it always fills with zeros. The leftmost bit, when we shift to the right, it always fills with zeros. So then we had the bitwise AND, OR, and XOR or exclusive OR. So AND is represented again with ampersand, but just single ampersand, not double. And OR is again vertical bar but single, and XOR is the the hat character. And some languages again use just these words, AND, OR, XOR. So AND, if we remember, it just returns 1 for the positions where both the bits with both operands have 1 at this position. So that bit will be 1. In all other cases it will be 0, or we'll return 1, or we'll write 1 in those positions where at least one of the bits of the operands is 1, and XOR will have 1 in the result only in the positions where both the operands, with only one of the operands is 1. So it's, if both are 0 or both are 1, it will convert it to 0 or result in 0. So that's a recap on bitwise operators. So type, let's see, there was one. So some languages provide the operators for getting some type information about your value or an expression or a variable. So again, this is not very, it depends on the language. So not all languages provides this, and the keyword of this operator is different, and there are 2 common ways or 2 common types of these operators. One is a Boolean operator, which means it returns a Boolean value and it evaluates the expression and returns. So it's a binary operator. You write expression or variable or a value, and then you say this keyword, which can be instance of or is or type of, and then you mention the type. So it checks if the given expression is of type, is of the provided type, and if yes, it returns true. If no, it returns false. So that's one type. And then there's another operator So some languages provide both, some languages provide just one of them, some languages don't provide any of this. So, but another group is when it's a unary operator, which you say type or type of, and then the argument, operand, which is again some expression and value and variable, and then it returns the type, some kind of notation of the type of this expression or the variable. So these are the type operators. I think all these groups cover pretty much all the basic, not basic, but most of the operators that the languages provide. And these, as I told you, all the operators have a type of evaluation, and in some cases it's always the same type, like conditional operators have Boolean. In some cases it depends on the operand. So for instance, addition, right? You take two numbers, you add them. So it depends on the types of the operands. It always works on numeric values, but if your values or operands are of type, let's say integer, then the result will be integer. But if your values are of type some floating point, let's say double, then the result will also be double. So the result type is not fixed, it depends on the operands. And then let's see, what else did I miss? So we mentioned postfix, prefix, we mentioned unary, binary, and then there is one ternary. We mentioned how they are written. So there is one more thing important about operators, which is called precedence. So precedence defines if you use basically multiple operators within the same expression, precedence is the priority of operators. So which one will be executed first, right? So it's similar to what we have in math, right? If you write a plus b times c, so times multiplication has higher precedence than addition. So b times c will take precedence. So it will be a plus b times c, not a plus b and then the result multiplied by c. So this in the same way, all these operators have precedence. So each language it might be a little different across languages. So, but in general, at least the common sense is preserved. So again, like multiplication will always have higher precedence than addition for numeric expressions. And if you want to change this precedence, if you want to explicitly say I want to perform this operator before this, you can always include that expression in parentheses, and then that will change the precedence. So yeah, I think this covers pretty much all of the operators, and let's spend some time in the next video to, since we already know about variables, we know about data types, and we can use this to form some expressions with operators. Let's just go through some examples, try to see, just knowing these simple things, can we solve something, do some useful calculation, or solve some useful task, or it's just some useless stuff for now and we need more information. So yeah, I think that's good for this video. Thank you very much. See you in the next one. Bye.